Okay, so today we are going to be talking about your old friend, the metric system. Doesn't that sound lovely? Now, the metric system uses units that are SI units. Do you know what SI stands for? I'd be impressed if you did. SI stands for International System. But why is it SI and not IS, you ask? Well, like many problems, it comes from the French. Because the French, just like in Spanish, they use the adjectives after the noun. So they say System International instead of International System. Just tell Mr. Natural Log, right? Anyways, now there's three basic units that we're going to worry about now. There are others, but we'll get to those much later. Now the first one is length. In the SI unit system, length is going to be measured in meters. We are going to use meters for length all the time, with very rare exceptions. Okay, now meters, now this is way too much writing for us in science. So what we do is we use an abbreviation, we use the lowercase m. And that is going to be the symbol for meters. Maybe you've seen it before. Wonderful. Now, for time, time is another unit that's important. Time is going to be measured in seconds. We are basically every time going to use seconds to measure. And that is going to be abbreviated with a lowercase s. Ta-da! Then the final is mass. Mass, we are going to use the kilogram. I'm sorry, chemistry, but we use the kilogram in physics instead of the gram. Chemistry uses the gram, but we do not. So that is one differentiation here. So many of the other units that you're going to be dealing with are going to be combinations of these three things. These three are like your basic building blocks. So for example, if you wanted to talk about speed, which we're going to do much later, speed is going to be done doing meters per second. If you want to talk about force, force is going to be talking about a meter kilogram divided by second squared. So it's a lot of your units for this first semester are going to be just combinations of these three basic measurements. These are the only measurements that you cannot break down at this point. Okay, now that we have those, we are going to have many different flavors of each one of those by adding a prefix. Alright, so we're going to start in the middle of this page here with no prefix. We're going to do an example. Let's stick with the meter. Right? Here's a meter. Now, to the right, we're going to go bigger. Now, if we have 10 meters stuck back to back, we are going to have something bigger than a meter. We are going to have a decameter. Now, a decameter is a weird one. It's got 2 letters for its prefix. Alright? Now, above that, if you stick 10 decameters together, you're going to have 100. I'm going to write 10 squared because I'm trying to be consistent here. See how it goes up by powers of tens? That's the classic trademark of the metric system. Now, oh, sorry, we should write the big words here. This is a deca. This is a hecta. Now, we're not going to write down hecta. It's a big capital H, so for meters, it's going to be H, lowercase m. Now, this works the same way for anything else, like grams. So this would be a decagram or a hectagram. We're not going to worry. We're just going to use meters as our example here. Now, 10 to the 3. 10 to the 3 is 1,000. It's an old friend. This is your kilo. So it's a lowercase k. So it's a kilometer, a kilometer, or a kilogram, as you're going to be using a lot. Now I'm going to put after this a star, because we are going to change scales. So after 10 to the 3, we're not going to go to the 10 to the 4. We are going to go to 10 to the 6. We're going to be going up by 3s now. So this was 1,000. Now we're up to 1,000,000. All right? Now 1,000,000 is mega. You might have heard of this before. It's a capital M. So you could have a megameter. Now, you've probably never done anything with a megameter, and that's okay. You've probably heard of a megabyte, though, and that is basically 1,000,000 bytes. Don't give me any of this 10 to the 20 or 1024. Okay, so we're going to go up one more time to 10 to the 9. 10 to the 9 is giga. So giga uses a capital G, so you could have a gigameter. You could have any of the other units too, but gigameter's good enough for us. Now, what we're going to do, is this good enough for you? They do keep going. You don't need to know them right now. Exa, zeta, not important. But what we're going to do is we're going to cover some of the smaller varieties. So we are going to go 10 to the -1, so that's 0.1. And this is a lowercase d because it's deci, like decimal. So this is a decimeter. It takes 10 decimeters to make a normal meter. All right. Below that, you have 10 to the -2. You might have heard this one. This is a centi. Lowercase c, lowercase c, lowercase m for centimeter. Okay. Keeping on going, we have 10 to the -3. You have milli here with 2 L's. So you have lowercase m. That's your millimeter. Now we are going to put a star here again because we're going to change scales just like before. We're going to have 10 to the -6. This is a millionth of a meter, or 1,000th of a millimeter. And this one is going to be micro. The abbreviation for micro is this funny letter. It's a Greek letter. This letter is mu. It looks like a U with a tail in front. It comes from makes the M sound in Greek, so that's why it's called mu. So if you wanted to write a micrometer, you'd put a micro, and then you'd put a meter. Ta-da! All right. So we're going to do a couple more. We're going to have 10 to the -9. I think that's the last one that matters to us. And this is going to be a nano, which is a lowercase n, and that's going to be a nanometer. Now, these are all the ones that you're going to realistically ever have to know. Some of these matter a lot more than others. Nano matters for light, micro matters for charge, millimeter and centimeter are just everyday common stuff. Decimeter isn't really that important. Neither is decameter or hectometer. Kilometer is important for real life, and these are just important for your digital life. So some of these matter more, but you should be familiar with just the stretch around the normal mark here. So now that we know these, we're going to do some conversions. So let's pretend we have, we'll say, 7,000 grams of gold. Do you feel rich yet? So I want to know how many kilograms that is, how many megagrams that is, how many micrograms that is. All right, so we got to do some unit conversions. Now I know some of you have done this and it's really easy, but some people haven't, and it will be a little trickier. The easiest way is to set up a little formula here just to get your bearings. So if I start out with 7,000, this is in grams. I want to cancel out grams. So grams is going to go down here. I want to convert it to kilograms. Now, do grams make a kilogram, or do kilograms make a gram? Well, I know that 1,000 kilograms, which is 10 to the 3, right, make 1 kilogram. 1,000 grams make 1 kilogram. So I'm going to be dividing 7,000 divided by 1,000. It's going to be 7 kilograms. All right. So I can do the same thing for the other one. So let's do once more into the breech. So we're going to have 7,000 grams. And then we're going to have cancel out the G, make the mg. Now, this time I'm going to have 1,000,000 grams make 1 megagram. So I'm going to be dividing by there, so I'm going to have 0.007 megagrams. Alright, we'll give you a chance. Pause the video, do the last one. Let's see if you did it right. So we're going to have 7,000 grams. Alright, this time, grams is still going to be on the bottom, micrograms on the top. Oh, micrograms. Oops, silly me. But this time, the micrograms make the grams. So we're going to have 10 to the 6 over 1 gram here. So this is going to be 7,000 million billion micrograms. Delicious, isn't it? And that's how you can do it. Okay, so we're going to do one more conversions. This one is to help you work in the world as you know. So we are going to talk about American units, or the imperial system, if you want to use its real name. So 1 inch is going to be equal to 2.54 centimeters. Alright, now this one's special because this one is exact. Alright, there is no rounding in that value there. But let's say you want to know another number. You want to know a bigger number here. So 1 mile is equal to 1.608 kilometers, which is also equal to 1,608 meters. You've dealt with this number before because it's 4 laps around the track for your mile run in your favorite class, gym, and 400 meters per lap. So I guess they just give you those last 8 meters if you can't take it. Last thing we're going to talk about is 1 kilogram. A kilogram is heavier than a pound, so that means that a kilogram is equal to 2.23 pounds. Alright, that's it. So this is just, you don't have to memorize these for this class, but this is just so you're educated for the real world. But you still got to know how to convert. So let's do a practice with these. So you are, we'll say 7.534 feet tall. What's your height in meters? What is the height in meters? So we want to tell our Canadian friend, how tall we are, so we got to convert it to meters. So let's do it. See, pause the video, see if you can convert it, and then we'll come back to you. Okay, let's see if you did it right. So we're going to start off with 7.534 feet. My first conversion is from feet. I'm going to convert it to inches because I don't know how to convert feet to centimeters or meters here. So feet to inches, I know that there are 12 inches in a foot, and that cancels out the feet, so I don't care about feet anymore. I only care about inches. So inches is going to go right there. What do I want to convert inches into? I want to convert it into centimeters because I have a conversion factor for that. Okay, so oops, there's 1 inch for 2.54 centimeters. But I don't want to end in centimeters, I want to end in meters. So I got to do it like this. I know that there's 100 centimeters in 1 meter, so centimeters cancels out. So what I'm going to do now is in my calc cheater, I'm going to type 7.534 times 12 times 2.54 divided by 100. And I'm going to get a number for that. And that number is going to be 2.296. And that's in meters. Remember to put a unit, because good people put units. Alright, so that's it for today. So hopefully you're feeling better with the metric system, or we reviewed it for you. Like and subscribe for more videos.